8286. 1. Generally, when a turbine engine indicates high EGT to a particular EPR, when there is no significant damage, it means that the engine is out of trim. 2. Some turbine-powered aircraft use RPM as the primary indicator of thrust produced. Others use EPR as the primary indicator regarding the above statements. A. Only one is true. B. Only two is true. C. Both 1 and 2 are true. The correct answer is C. Statement 1. Generally, when a turbine engine indicates high EGT, exhaust gas temperature, for a particular EPR, engine pressure ratio, when there is no significant damage, it means that the engine is out of trim. EGT is an indication of the temperature of the exhaust gases, and EPR is a ratio of the exhaust gas pressure to the engine inlet air pressure. When the engine is out of trim, it means that the engine parameters are not properly balanced, resulting in a higher EGT reading for a given EPR. Statement 2. Some turbine-powered aircraft use RPM, rotations per minute, as the primary indicator of thrust produced, while others use EPR as the primary indicator. RPM is a measure of the engine's rotational speed, and EPR is a measure of the engine's thrust. Different aircraft may have different instrumentation configurations, with some using 8287. Engine pressure ratio is determined by A. Multiplying engine inlet total pressure by turbine outlet total pressure. B. Dividing turbine outlet total pressure by engine inlet total pressure. C. Dividing engine inlet total pressure by turbine outlet total pressure. The correct answer is B. Engine pressure ratio, EPR, is a measure of the pressure ratio between the turbine outlet and the engine inlet. It is determined by dividing the turbine outlet total pressure by the engine inlet total pressure. In other words, EPR equals 0.3/0.2, where 0.3 is the total pressure at the turbine outlet and 0.2 is the total pressure at the engine inlet. The EPR value provides an indication of the engine's performance and can be used to assess the thrust or power output of a turbine engine. 8288. Turbine engine EGT thermocouples are constructed of A. Iron and Constantan. B. Copper and Constantan. C. Chromel and Alumel. The correct answer is C. Turbine engine exhaust gas temperature, EGT, thermocouples are typically constructed using Chromel, an alloy of nickel and chromium, and Alumel, an alloy of nickel, manganese, aluminum, and silicon. These alloys are chosen for their specific thermoelectric properties, which allow them to generate a voltage in response to the temperature difference between the hot exhaust gas and the cooler reference junction. The Chromel-Alumel thermocouple combination is commonly used due to its stability, accuracy, and ability to withstand high temperatures typically encountered in turbine engine exhaust gases. 8289. Which of the following instrument discrepancies require replacement of the instrument? A. Red line missing from glass, glass cracked, fogged. B. Glass cracked, will not zero out, pointer loose on shaft fogged. C. Will not zero out, red line missing from glass, glass cracked. The correct answer is B. When an instrument displays the following discrepancies, it typically requires replacement. Glass cracked. A cracked glass can compromise the integrity of the instrument and affect readability. It is recommended to replace the instrument in such cases. Will not zero out. If an instrument cannot be properly zeroed or calibrated, it indicates a malfunction or calibration issue that may impact its accuracy. Replacement is usually necessary. Pointer loose on shaft. A loose pointer can result in inaccurate readings or erratic movement. To ensure reliable operation, the instrument should be replaced. Fogged. If the instrument's glass is fogged or obscured, it can hinder visibility and affect the pilot's ability to read the instrument accurately. In such cases, replacing the instrument is advised. 8290. A Bourdon-tube instrument may be used to indicate A. Pressure and temperature. B. Pressure. C. Temperature. The correct answer is A. A Bourdon-tube instrument is a type of mechanical gauge that can be used to indicate both pressure and temperature. The Bourdon-tube, which is a curved metal tube, is the primary sensing element in the instrument. When subjected to pressure, the Bourdon-tube flexes or expands, causing the pointer on the instrument dial to move and indicate the corresponding pressure value. Additionally, by incorporating appropriate mechanisms and components, the Bourdon-tube instrument can also measure temperature using the same principle of expansion or contraction in response to temperature changes.